Once upon a time, there was a game engine announced that would be revolutionary, that would change the way that we saw games forever. Everything could be rendered in real time and look beautiful, realistic, and be accessible to almost any developer you could think of. And with that came out Unreal Engine 5. And ever since that has happened, it's been a pretty big dumpster fire. Not gonna lie, it's not like it's a bad engine. The games don't look bad, and you can use it properly, but almost every single example that we've seen hasn't been that great, and the reputation for Unreal Engine 5 nowadays has been terrible. Like, I just made a video on Silent Hill F, which utilizes Unreal Engine 5, kind of like how the Silent Hill 2 remake did, and that game didn't go that well in terms of optimization, performance, and bugginess that can happen even on optimized platforms like the PlayStation. You know, Silent Hill F came out. I made a video because there's this guy on YouTube that basically said this game needs to be upscaled from as low as 360p. How are we in a state where just to make a game function and get 60 FPS, it has to upscale from 360p? That sounds insane. What's actually funny is throughout this video, I proved that this guy was actually wrong. I have no clue where he got these resolutions from. Doesn't make sense to me. I don't have a PlayStation, so I can't confirm that for myself. But basically what I did is I reconstructed a PlayStation on PC. The performance was a lot better. Then you go to the comments of this video, and a lot of people that responded on it are just saying things like this: it's evolving, just backwards. AI upscaling was supposed to enhance games, but instead it just made devs not optimize at all anymore. So a lot of people are just looking in the comments and, you know, seeing the first impression of the video and the assumption, because Unreal Engine 5 is so rough, that it is going to be bad. And this concern is not unwarranted at all. Almost every single damn game that runs this engine runs like shit. Which this whole trend was kind of started by a very special game. This is called Black Myth Wukong. Now you guys have probably heard about this. This game has sold an unbelievable amount of copies. 2.4 million concurrent players 14 months ago when the game came out. Like, this game was extremely popular. It was very, very big in China, but it was still pretty popular here. This game most likely sold over 25 million copies. And honestly, it deserves it. It's a very fun game. The problem with it though is it was also Unreal Engine 5. It was also extremely hard to run. It relied on things like upscaling. I remember playing on an RTX 4060, which is a very mainstream, very popular graphics card on PC. In order to just get 60 FPS at 1080p, you had to play it like medium settings, because if you played at high settings, you would easily dip below 60 FPS. And also this game had a weird problem where it would just felt laggy. And there's like this thing on PC called NVIDIA Reflex. Even though your frame rate could vary quite a bit, it could keep your latency pretty good. This game did not have Reflex at launch. You couldn't turn it on without turning on frame generation. And I don't really want the fake frames all the time, especially if my frame rate's a little bit too low at base, because it makes it unresponsive and stuff. We've been through the whole frame generation discussion, but this game heavily leaned on things like app scaling and frame generation. And this is concerning because our hardware and the prices that our hardware is at nowadays on PCs isn't getting like a ton cheaper. The features that they're adding, like multi-frame generation, isn't really making the gaming experience like absurdly better or anything like that. And it's concerning because it seems like they have at least plans to make a DLC for Black Myth Wukong, and it would still probably be built in Unreal Engine 5, which means there'd be more game that people would have harder times running. Nowadays, actually, this concern has changed a little bit because they're releasing another game. They're called Black Myth Zhongqi, I think how you pronounce it. And this game, I'm guessing, will also be built on Unreal Engine 5 because it's in development right now. So just in respect to the Black Myth games, it concerns for the future of this thing. Like, are people going to be able to run these damn games without buying like a freaking used car price PC? It just doesn't make sense. Well, the developers of this game, Game Science, I guess it's been reported, they basically fixed Unreal Engine 5. Basically, there was this patch announced that it would be making significant... My dad just sneezed upstairs. Bless his soul. You know, Black Myth Wukong patch makes significant performance improvements, but brace yourself for a 93 gigabyte download on PS5. But major performance improvements. What can we get out of this? Is this engine salvageable? Let's see what they did. What's funny with all this game optimization stuff is maybe you think you can do it better. And maybe you actually can. With today's sponsor, Boot.dev. Gaming inside of a game while you're also making that game. It's an insanely mind-boggling statement, which basically is how I've always seen code. But this is changing though, and it's because of boot.dev for me. They are genuinely getting me hooked. I've been working on Python so far because it can integrate into my editing program, and I've been wanting to tackle some projects I wasn't sure if I was ever going to be able to do. Now, boot.dev has a huge focus to teach you back-end development and also web development. Expanding on that, there are tons of courses in Go, C, SQL, Java, Git, Docker, and even Linux. While this all sounds super daunting, they do an amazing job at easing you into it, especially with the gamifying portion of this. It works, and it's very charming and keeps you on. Basically, you can accumulate XP, shield, health, streaks, and even chess. This creates a great community that I'm definitely going to be reaching out to when I need the help. All these lessons are actually free to read and watch. The interactive stuff and progression comes with the membership, but a free demo of that is available for each course. So check out boot.dev and you can use my code VEX for 25% off your entire first year on the annual plan. They've been very smooth to work with and tons of respect to them so far. I'm really enjoying boot.dev, so thanks for them for sponsoring this part of the video. Make sure to check them out. Let's jump back in. Because if you jump into the old versions of the game, oh man, it did not really look that good. So there are 5 main gaming settings for this, at least settings presets. So there's a low, there's medium, there's high, very high, and then cinematic. And cinematic was one that was causing a lot of controversy. Cinematic graphics in Unreal Engine 5 is usually left for cinematics, like literally the animations and cutscenes that are within games, but they gave us access to the settings configuration. And if you look at the game on cinematic, it does look very, very good. Like if you have the hardware to take advantage of this, it looks pretty incredible. But most people don't have that, so a lot of people are gonna be turning their settings down to like low. And if you compare low to cinematic, the game looks completely different. It's like all of the lighting kind of just went away. And one of the things that really bothers me too, especially on the lower graphics settings, is you start to just run through the game. Shadow detail does not draw into you, like around the character until it's like a foot in front of the character. I think it's very distracting. And that does get fixed with things like cinematic, or if you want to turn on ray tracing within the game, the ray trace shadows will fix that problem as well. But overall, the level of detail within the game and the lighting quality when you can play at decent settings is pretty good, but makes a lot of compromises on lower settings within the game with like reflections, hair detail, everything. It just does not look that great. But sometimes you have to utilize dropping the settings within the game. Like for example, on the RTX 4060, if you play at low settings at 1080p, you can get 113 FPS on average here. Notice that sometimes it will dip lower, but you know, our performance isn't terrible on low settings, but the game is very, very visually compromised. Up this to medium settings to get some more visual quality, you're losing 22% of your performance to get that. If you jump up to high settings from low, then you're losing 42% of your performance, and honestly, you're only getting on average over 60 FPS, but if you look at the 1% lows, they're only at 44 FPS, which means the game is a pretty stuttery experience. If you want to up settings even more to solve some of the issues that high settings has, if you're playing on this mainstream graphics card, you're only gonna get 46 FPS. And this especially is an issue if you want to go up in resolution. Like you have a $300 card, 1440p monitors are relatively cheap nowadays. On low settings, 1440p, you get 74 FPS. And if you want to fix how the graphics look, you're losing 19% of your performance in order to do that. And then basically high settings isn't really playable without upscaling at 1440p on the RTX 4060. This is an action RPG game, so you do want probably at least 60 FPS. And at least nowadays they have added and fixed the whole reflex situation, so the game is pretty responsive. And these kind of performance losses as you turn up the settings is pretty common throughout a lot of different graphics cards. Like for example, on the $430 RTX 5060 Ti, 16 gigabyte. At 1440p, going to medium settings from low, you lose 20% of your average frame rate, and you lose 39% of it if you want to go to high settings. Those are just some of the examples that these graphics cards can go through. Like you generally lose a lot of your performance by turning up the settings in this game. And it really makes you decide if you want to play at a shitty looking quality with decent performance, or take a huge hit, have more instability, but have a decent looking game. What's funny is this game does rely so much on upscaling, especially being based on Unreal Engine 5. What's funny is they added DLSS 4 support, but they only added that actually for the frame generation features, because if you look in the game settings and even if you compare some things, you can actually force the game to use the newest version of upscaler through NVIDIA's driver, and the performance difference is different. A bigger AI model overall, and the visual quality can look better with it, but the newest version of DLSS does take a performance hit, so that's probably why they didn't end up using it. Now, I did all those benchmarks and the visual testing the exact moment that I found out that the new patch was coming, because I really wanted to see this for sure. But let's look at what the patch notes are, and if they really do fix Unreal Engine 5, is it even possible? This is a pretty big one, because up to this point in time, AMD graphics cards, their new ones actually have a new upscaling technology available to them, but it does need to be partially integrated into games. They integrated FSR 4 support. I'll show you how to use this later. It does work. They also improved the compatibility mode. They adjusted the default graphics settings for graphics cards on various graphical changes in the current game version. So a lot of graphics in the sentence there. Maybe this will run better at default for a lot of different graphics cards out there. The big thing that I want to take a look at here is they significantly improved the lighting quality, allegedly, when global illumination is set to low, making it closer to the effect when global illumination is set to high, as we saw with the visual tests between like low and even high settings. A lot of the problems with that is actually the global illumination. This is like, how does light bounce around in the space? How are shadows going? How is color being casted onto different objects? Is there ambient occlusion? Global illumination does all of those type of things. And it seems like the major issue with low settings and why it looks so shitty is because global illumination basically just doesn't exist on low settings. So what they're claiming here is that you should get similar lighting quality on low as if it was set to high. Also, they said they improved the CPU rendering performance in numerous scenarios. I honestly didn't know they were going to improve this or whatever, so I didn't actually test this specifically. They said they improved memory usage in numerous scenarios. Basically, there should be some better optimization here, as well as FSR 4 support. And this is a major step for them, because on their next game they're probably going to release, there's a Q&A on their website for the Zhang QE game. On what platforms will Black Myth Zhang QE be launched? They said on PC and all mainstream console platforms, which is interesting because, yeah, it's expected to be on like a PS5 or PS6 or whatever's out at the time. Also, though, you'd expect this, because it's all mainstream console platforms, this might be on the Nintendo Switch 2. It's gonna need quite a bit of optimization to get it running on a Switch 2. So let's look at how this actually performs on some different graphics cards. We're gonna be comparing the old patch to the new patch and some of the findings that I got. So on low settings, we see that the 4060 gets now 118 FPS compared to 113 before on average. And that makes it 4% faster on low settings. So it's interesting that they're claiming better lighting quality and everything, and it's also getting better performance on the new patch. And if we go up to medium settings on both patches, then we get a 7% improvement to the performance, which is pretty cool, but you might already see some issues that at least I'm seeing with the way this is looking right now. Now, if you jump up to high settings on the 4060, getting only a 2% improvement between these patches. And to be honest, that's one frame, so probably this is due to margin of error. How up to very high settings, 0% improvement. How about to cinematic settings? 0% improvement as well, which seems to be a common trend between a lot of the graphics cards that are out there. And we hop up to the 5060 Ti 16GB at 1440p low settings is a 5% improvement on the new patch, so not bad, getting more performance. 9% improvement on medium settings, though the 1% lows to how stuttery the game isn't as better or whatever. Now, how about the high settings? It is 2% faster. Again, only one frame difference. So honestly, margin of error at the end of the day. The 5070 Ti from NVIDIA is a similar thing. You know, you get some amount of performance boost on low settings and on medium settings. But if you hop up to like high, very high, then the performance improvement is pretty much margin of error. This doesn't actually seem to be the same situation on AMD graphics cards compared to NVIDIA ones. Now, just for reference, NVIDIA graphics cards tend to have a pretty big advantage in Black Myth Wukong, probably because this is built on an NVIDIA fork of Unreal Engine 5, so definitely no colluding going on there from NVIDIA. Now, the AMD card, it's interesting, on the new patch, if we hop up to 1440p on the 9060 XT 16GB, then on low settings, you actually get a 2% improvement, which is only a couple frames. And honestly, that's probably about margin of error. However, the 1% lows, how stuttery the game is, actually a little bit worse on the 9060 XT on the new patch. If we go to medium settings, you get a decent performance improvement. 9% going up to 82 FPS on the new patch. And the 1% lows are about even here. I'd say they're only 1 frame difference. Go up to the 9070 XT, which is a $600 graphics card. It's supposed to be $600, but realistically, real world, 9070 XT is about $680. On low settings, there is no average frame rate improvement going to the new patch. However, the 1% lows are actually worse. So the performance is looking worse on this new patch on this particular graphics card. However, you jump up to medium settings, and just like how we saw on the 9060 XT AMD card as well, you get an 8% improvement on average. Now, the 1% lows are only basically margin of error, 1 frame difference, but on average, you get a decent performance improvement. And you get a little bit of an improvement at high settings. Again, this is probably about margin of error. And also, just for reference, on the ray tracing presets in the game, low, medium, and very high ray tracing is what's available. And honestly, the performance was about the same. So overall, performance-wise with this patch, it seems like going on low settings, we get better performance. And on medium settings, we get decent performance as well. But as you go up in the settings presets, it doesn't tend to change on basically any of the graphics cards. But you might have noticed throughout these tests, especially on like low and medium, there's a pretty drastic settings difference between how the games look. I don't know if it's actually an improvement. But if you like stand here, look into like this little like gate basically. While the old low settings basically didn't have lighting, it didn't really seem like it did. The new settings have a weird way of going about it, where almost everything feels very flat. There is some lighting detail, but a lot of I think the ambient occlusion isn't really coming in here. It looks kind of odd to me. And one of the most bizarre things that I found on so many of the examples is when you go up to medium settings. Medium settings have taken a drastic hit to the visual quality between these patches. It genuinely looks worse. You can just see the flashing that is going on within the distance on medium settings. And this seems to be some of the problems with the new global illumination that's going on within the game, of how this interacts with the volumetric detail. So like fog, clouds, everything like that. And this is even using the best version of DLSS that's available on both versions of the game. This shouldn't be an upscaling problem. I think that this looks super odd, especially as you go down in resolution on some of these lower end cards and you want to play on medium settings. It is very clear that there is a visual degradation going on the new patch. So this is one of the things that blew me away. Now, as we go up to like high settings and stuff, the game doesn't look drastically different between the patches at all. Even when we turn on things like ray tracing, I don't think the game really looks that different. What actually makes me laugh about ray tracing in this game, when you turn on ray tracing low, you take a huge hit to your performance, right? However, you go into scenes like where there's a big reflection, and ray tracing low actually doesn't do any reflections with ray tracing. You have to go up to medium or very high in order to get those. So in certain scenes, when there is a big reflection in the scene, it's just gone. Even though you're taking a huge hit to your performance, it makes no sense to use ray tracing a lot of the time in this game. I just still think it's extremely poorly optimized, and this did not change from the patches at all. You know, as we dig into it, yes, there is some performance improvements within these, but I think that the visual like compromises that they made don't seem to make sense. I think the low settings with the global illumination and everything looks maybe a bit better than it did before. Like I did run some tests with it just changing the global illumination setting itself. It does look a little bit better in isolation, like if you're not changing the entire settings preset. However, most people are probably going to change the entire settings preset, let's be for real. Now, on the AMD graphics cards, they did add FSR 4, which is pretty sick because this game does rely on upscaling so much. And genuinely, there's a pretty large visual improvement between these. Like, just look at FSR 3.0 that was on the old patch on the left, and then FSR 4 that's on the patch on the right. Like the detail that's being reconstructed, the stability, the issue, I guess, if you have an AMD card, it will default in your driver to enable FSR 4 in all games by default. But when you turn it on in the game, you still have to restart the game to use FSR 4 for some reason. I don't know why exactly. It's not perfectly fluid. And at least with the new patch too, they also fixed the settings menu. Before, they were still showing Chinese within the settings menu. It's the English version. You know I'm on the English version, but for the latency and the frame generation metrics in the settings, they would show in Chinese, and I had to use Google Translate on my phone in order to figure out what the hell they're talking about. It was like that for like 6 months. It was crazy. Basically, they set out to possibly fix Unreal Engine 5. And the more and more I see games launch with Unreal Engine 5, the less and less I think it can actually be solved or fixed. Especially if you want to use the new technologies like Nanite and Lumen. I think these things at a baseline level, though they can really help with game development, with how fast you can get things going, especially good in a game like Borderlands 4 because it is a dynamic lighting system. That's what Lumen is good at doing. And Nanite is a dynamic LOD system. Now, what's disappointing about Black Myth Wukong is this is not an open world game. It has set levels. Daylight doesn't change. Realistically, this game does not need a fully dynamic lighting system in order to look good. And that's why it's so disappointing to see how poorly it runs. And it's taking advantage of some of these technologies. Could run so much better if they use things like baked lighting or even like probe lighting in order to do this stuff in the game. But instead they prioritized the features that were in Unreal Engine 5 and just relied on them being super heavy to run and putting more of that load on our hardware and relying on things like upscaling and frame generation to account for those problems. So it is a pretty frustrating situation for me, and it doesn't seem like they're able to fix that with this. If we want better performance and everything, it's not like you can't build a game that runs well in Unreal Engine 5, but if you want to use the new technologies, then it's going to struggle. But that's kind of a lot of the reason why developers want to use Unreal Engine 5 is for Nanite, is for Lumen. But that's the situation that we're looking at, and this is how every single time it has played out, which has blown me away. But yeah, when they announced this patch, I wanted to check it out. I wanted to see if they could actually make a dent in this thing, and they have proven me right again that this doesn't seem like it's going to ever be fixed with this engine, which is a shame because of how many developers want to use it and how useful it actually is. Also, check out boot.dev in the description. That website is sick, I'm not gonna lie. That's been about it for me today. Hope you guys have a good one. I'm gonna see you next video. Peace.